Humans have always been explorers. From the earliest days of our existence, we have been driven by an insatiable curiosity and a relentless desire to discover what lies beyond the horizon. We crossed vast oceans in fragile wooden ships, braving the unknown to find new lands and new opportunities. We scaled towering mountains, pushing our physical and mental limits to reach the highest peaks on Earth. And in the 20th century, we took our first steps beyond our home planet, landing on the moon and exploring its desolate surface. The moon landing was a monumental achievement, a testament to human ingenuity and determination. It showed us that with enough effort and innovation, we could overcome seemingly insurmountable challenges and reach for the stars. But what about leaving our galaxy? The Milky Way, our cosmic home, is just one of billions of galaxies in the universe. Each galaxy contains billions of stars, and around many of those stars, there are planets that could potentially harbor life. The idea of venturing beyond the Milky Way and exploring these distant galaxies is both thrilling and daunting. What about venturing beyond the Milky Way and into the vast uncharted territories of intergalactic space? The distances involved are almost incomprehensible. The nearest galaxy to us, Andromeda, is over 2.5 million light-years away. Traveling such distances with our current technology would take millions of years. The very idea seems impossible, a dream confined to science fiction. Yet, science fiction has a way of inspiring real scientific advancements. Many of the technologies we take for granted today, such as smartphones and the internet, were once the stuff of science fiction. Could intergalactic travel one day become a reality? But is it truly out of reach? Advances in physics and engineering could one day make it possible to travel faster than the speed of light, or to use wormholes to traverse vast distances in an instant. These concepts are still theoretical, but they offer a tantalizing glimpse of what might be possible in the future. Can we someday conquer the ultimate frontier and leave our cosmic cradle behind? The challenges are immense, almost unimaginable. We would need to develop new forms of propulsion, new ways of sustaining life in the harsh environment of space, and new methods of communication across vast distances. The challenges are immense, almost unimaginable. But so were the challenges faced by the first fish that dared to crawl onto land. Life on Earth has always been about overcoming challenges and adapting to new environments. The transition from sea to land was a monumental leap, and it paved the way for the incredible diversity of life we see today. The spirit of exploration is deeply rooted within us, driving us to push boundaries and seek the unknown. This same spirit has taken us from the depths of the ocean to the surface of the moon, and it will continue to drive us as we look to the stars and beyond. And who knows what wonders await us in the space between galaxies? The universe is vast and full of mysteries. There could be planets with conditions perfect for life, or even civilizations far more advanced than our own. Perhaps other forms of life, exotic energy sources, or even entirely new laws of physics. The possibilities are as limitless as the universe itself. Discovering these wonders would not only satisfy our curiosity, but could also provide solutions to some of the most pressing challenges we face on Earth. Or even entirely new laws of physics? The quest for knowledge and understanding drives us to explore the unknown, and the potential discoveries in intergalactic space could revolutionize our understanding of the universe and our place in it. The possibilities are as limitless as the universe itself. But before we can even begin to contemplate such a journey, we must first grapple with the sheer scale of the cosmos and the mind-boggling challenges that intergalactic travel presents. The distances are vast, the environments are harsh, and the unknowns are many. But before we can even begin to contemplate such a journey, we must first grapple with the sheer scale of the cosmos and the mind-boggling challenges that intergalactic travel presents. Only then can we begin to imagine a future where humans might one day set sail for other galaxies. It will require unprecedented levels of cooperation, innovation, and determination. But if history has taught us anything, it is that when humanity sets its sights on a goal, no matter how impossible it may seem, we have the capacity to achieve it. The dream of intergalactic travel may seem like a distant fantasy today, but with each passing day, we move one step closer to making the impossible possible. The Milky Way, our home galaxy, is breathtakingly vast. Stretching across the night sky, it appears as a faint, milky band of light. But in reality, it is a colossal structure teeming with stars, planets, and cosmic wonders. Imagine this. It takes light, traveling at an astounding 186,000 miles per second, the fastest speed in the universe, to traverse the Milky Way. About 100,000 years to cross it from edge to edge. This means that even at the speed of light, the journey across our galaxy is a monumental trek. That's right, 100,000 years. To put that into perspective, if you started your journey at the dawn of human civilization, you would still be traveling today, with countless generations having come and gone. To put that in perspective, modern humans have only existed for about 200,000 years. In that time, we have evolved from primitive beings to a species capable of exploring the cosmos, yet we have barely scratched the surface of our own galaxy. Within this vast cosmic ocean, our sun is just one of hundreds of billions of stars, each a potential host to its own system of planets, moons, and possibly even life, each potentially orbited by its own family of planets. These exoplanets, as they are known, could harbor environments vastly different from our own, some perhaps even capable of supporting life. The sheer scale of the Milky Way is almost impossible for our earthbound minds to truly grasp. Our planet Earth is just a tiny speck in this grand cosmic arena, a mere dot in the vast expanse of the galaxy. And yet, this is just one galaxy among billions upon billions in the observable universe. Each galaxy, like the Milky Way, is a vast island of stars, each with its own unique structure and history. To even think about leaving the Milky Way, we must first acknowledge the daunting distances involved. The edge of our galaxy is so far away that it challenges our very understanding of space and time. Even reaching the nearest star system within our own galaxy, Alpha Centauri, remains a monumental challenge. At over 4 light-years away, it would take tens of thousands of years with current technology. It's like trying to cross an ocean in a rowboat when we haven't even mastered sailing across a lake. The journey to the stars is a testament to human curiosity and our unyielding desire to explore the unknown, but it also reminds us of the vastness of the universe and our humble place within it. The distance between galaxies is not just vast, it's almost unfathomable. When we look up at the night sky, the stars we see are just a tiny fraction of the universe. Each point of light represents a star, many of which have their own planetary systems. But beyond our Milky Way, there are billions of other galaxies, each containing millions or even billions of stars. The scale is truly mind-boggling. The Andromeda galaxy, our closest galactic neighbor, is a staggering 2.5 million light-years away. This means that the light we see from Andromeda today actually left the galaxy 2.5 million years ago. We're essentially looking back in time, seeing Andromeda as it was long before humans even existed. This means that even if we could travel at the speed of light, a physical impossibility according to our current understanding of physics, it would still take 2.5 million years to reach it. Light speed is the ultimate speed limit in the universe. And yet, even at this incredible velocity, the distances between galaxies remain daunting. To put that into perspective, 2.5 million years ago, our ancestors were still using simple stone tools. They were just beginning to understand how to use fire and were far from developing the complex societies we know today. The sheer length of time it would take to travel to Andromeda at light speed is almost beyond human comprehension. The pyramids wouldn't be built for another 2.495 million years. This comparison helps us grasp the enormity of the timescales involved. Human civilization, with all its achievements and advancements, is just a blink of an eye in the cosmic timeline. The distances involved in intergalactic travel make even our most ambitious space missions seem like short hops across the street. The International Space Station, for example, orbits just a few hundred kilometers above Earth. Even our missions to the Moon and Mars are relatively close by when compared to the vast distances between galaxies. Traditional propulsion systems, like the ones that power our rockets today, are simply not up to the task. These rockets are designed for short-term missions within our solar system. They rely on chemical propulsion, which, while effective for reaching nearby planets, is not suitable for the immense distances of interstellar travel. Chemical rockets, while powerful, are incredibly inefficient for journeys of this magnitude. They require vast amounts of fuel, which adds significant weight and limits the distance they can travel. For interstellar travel, we need to think beyond traditional propulsion methods. We need a revolutionary new approach to propulsion, something that can allow us to cover unimaginable distances in a reasonable time frame. Concepts like nuclear propulsion, ion drives, and even theoretical ideas like warp drives and wormholes are being explored. These advanced technologies could one day make interstellar travel a reality, opening up the universe for human exploration and potentially finding new homes among the stars. Let's talk fuel. To propel a spacecraft across the immense gulf of intergalactic space would require an astronomical amount of energy, far exceeding anything we can currently produce or even conceive of. Traditional chemical rockets, which rely on burning fuel to create thrust, simply wouldn't cut it. Imagine trying to fill a car's gas tank with enough fuel to drive around the Earth 1 billion times. That's the scale of the challenge we're facing. We need to explore entirely new forms of energy, perhaps harnessing the power of antimatter annihilation or tapping into zero-point energy, a hypothetical energy field that exists even in a perfect vacuum. But even if we could somehow solve the energy problem, there are other, equally daunting challenges to overcome. The human body, fragile and adapted to the conditions of Earth, is ill-equipped for the rigors of deep space travel.